Yeah. So hello everyone, this is Varash here and welcome to Acid, Bases and Salts Day 4. So this is going to be the last part of our chapter. So this is our fourth chapter. Our first chapter was ionic charge, next was nutrition in plants. And again, we dealt with matter, and now this is our fourth chapter. So this is going to be the last part of it. So in the previous video, we have dealt with indicators. So now we know about acids, we know about bases, what are the differences between them, we know a lot about them, and we know how can we identify them by using different indicators. Now this is the last part where we are going to learn about salts or a process called neutralization. Now first, neutralization. When we hear about this word neutralization, it has two parts. So first, when we hear this word, you see something called neutral. Now, we know what are neutral substances, right? So, from this, we get an idea that it is related to neutral substances. So, what is a reaction in which an acid and a base nullify the effect of each other to form a salt and water. Heat is also evolved, thus it's exothermic. So what does this mean? Is that neutralization is basically it's a process which is happening in the everyday world. Now what is this process? In this process there is an acid and a base. Both of them are added, like there is a cup of acid and there is a cup of base and there is another empty cup. So you add 1 drop of acid or some 10 ml of acid and 10 ml of base. So when you add an acid and a base, or we can say acid plus base, when we add an acid and a base, what is this reaction? That process is known as neutralization. So what happens in neutralization? An acid and a base come together. Now what is the product? Now basically if there is a chemical reaction, we know that one side is the reactants which are going to react and the other side is the products. So we know that the reactants are 1 acid and 1 base and the products are 1 salt and 1 water. Salt is nothing but it's a substance which is formed by this process. So even the common salt you use in cooking is formed by neutralization in water, and even water is evolved. Even water is there in this process. Water is also a product. So acid plus base equivalent to salt plus water. Heat is also evolved, thus it's exothermic. Now we have many reactions and we know that they can be exothermic or endothermic. This one is exothermic, it releases heat. And next, some examples of neutralization are HCl, hydrochloric acid, plus NaOH, equivalent to NaCl plus H2O. HCl is an hydrochloric acid, NaOH is sodium hydroxide, it's a base, it gives rise to sodium chloride. It's the common salt we use in cooking. NaCl is the common salt we use in cooking. And water, another example is HNO3 plus KOH, equivalent to KNO3 plus H2O. It's a chemical change. Neutralization is a chemical change. So now from this one slide, we have understood what neutralization is and what a salt is. So this brings us to the end of the chapter, but we have one more topic to cover, okay? So these are some real life examples of neutralization. So let's deal with one by one. Okay, so the first picture which is there, it shows about indigestion. Now, when there is indigestion, it means that you have a lot of acid in your stomach. So let me explain it to you in a very clear way. Now, you have your stomach, and then there is an acid called the hydrochloric acid. Now, as we know that hydrochloric acid is a really strong acid. So, how our stomach should burn. So, right, but there is a lining of mucus which protects the stomach. In some cases, if we do not eat food at the proper time, what happens is the HCl starts refluxing, which causes the indigestion. So that is why you need to eat food in a proper time. So when there is a case of indigestion, there is a very simple way to treat it. Even you can treat it. You go out and somebody has indigestion and acid reflux. You need to use a very simple logic and treat them. First thing is, and this is caused by an acid reflux, correct? So there needs to be a base to reduce the effect of an acid. Okay, so there needs to be a base to reduce the effect of an acid. And the acid is HCl, the base can be an antacid. So when we learned about bases, we learned about antacids. Now antacids are like eno, etc. They are antacids, they are bases basically. So they are bases which are taken to neutralize the effect of an acid. This is one real life example of an new base neutralizing an acid. Okay, next, ant bite. Now when there is we have ant bites, right? Once in your life you might have an ant bite, and it forms a red kind of thing, and it is very itchy too. So what is the science behind it? Ant bite releases formic acid. This formic acid which is there, that is what it causes, like the red thing on your skin. So to neutralize that effect, we use a base, which is a calamine lotion. Calamine lotion which you use, it's a base to neutralize the effect of an acid. Next, what is this? This is some factory waste being used, which is being thrown into the river. Of course, it's a really bad thing, and we have to stop it. But humans are not in a way to stop it. So basically, this factory waste has a lot of acid in it. It's being neutralized with a base so that the water doesn't get acid, a lot of acidic, but it's polluted only. So yeah. Now this is the most good example. In the first three cases, we have seen a base neutralizing the effect of an acid. Now in this case, we'll see both. Now this is what we call as soil. Now soil is where the plants grow. The plants cannot grow if the soil is too acidic or if the soil is too basic, right? So if the soil is too acidic, there need to be some bases to nullify the effect of an acid. Now bases like quicklime and slaked lime can be added to treat the effect of an acid. But if the soil is too basic, organic matter is added, like the organic matter, the biodegradable waste. These waste release some acids into the soil and make it a neutral soil. They neutralize it. So this is one case where a base can neutralize an acid, and even an acid is neutralizing a base. So there are millions of examples. Suppose there is bacteria in your teeth, they release some acids, and to nullify the effect of an acid, we use toothpaste. It's another example. So like that. Now in the last video I've told you that I'll give you a test. Now I haven't written it, but I will tell it by words. Okay, so first question, there are substances given. Okay, there is a cool drink seller. He is like, person A wants as an acidic drink, person B wants basic drink, person C wants neutral drink. He has a litmus indicator. How will he give what drink to what person? So first bottle A and to person A. So first bottle A, if we keep the litmus, it will, if it turns red, then it's gonna be to the person who wants acidic drink. Now bottle B, if it turns blue, it will be to the person who wants a basic drink, and if there is no color, to the person who wants a neutral drink. Next. Why does a turmeric stain on a white shirt change into red color if it is washed with detergent? Now we have discussed this earlier also. When there is a base added to turmeric, it turns into red. That is the reason the turmeric stain turns to red. Okay, next question. You have a blue litmus paper and a colorless solution. The colorless solution changes into blue. Is it an acid, base, or a neutral? Now this is going to be a really tricky question. Now we have only blue litmus paper, okay, and it is changing into blue only. So if it is a base, it changes into blue. Yeah, so it might be a base, and if it's a neutral, it doesn't change color. So blue doesn't change color, it remains blue even in neutral. So that particular substance can be basic or neutral. So end of the questions. Now we have ended this chapter, acid, bases and salts. Hope you have liked it, and we have completed the chapter. In our next video, I'll come up with a new chapter for you guys. Until then, bye bye.